Welcome to It Matrix. It is your time finally for physical sciences on a Tuesday with Looney and TK. How are you, TK?
I'm good, and you, Lenny?
I'm good, thank you. What are we doing today?
Well, today we're going to look at a topic called, or a section of work called fertilizers. So that's what we're going to be talking about today.
All right. Mindsetters, you heard it. We're doing fertilizers today with TK. I hope you guys are pumped and you're excited, just as I am for this lesson. Remember to talk to me on Facebook and on Twitter. Our Facebook page is facebook.com/learnextra. Our Twitter handle is @LearnExtra. Remember, you can download the show notes, the videos, and the schedules, and check out everything else we have to offer here at Mindset on learnextra.co.za/live. I do post all the notes on our Facebook page, so make sure you are on the lookout for that. Thank you so much to Macmillan for bringing us this great show. And with all that said, I'll hand it over to TK.
Thank you, Lenny. And we go straight away to the lesson. Like I said, we're talking fertilizers today. So this is a section of work that we are to do, and obviously it's going to be part of the exam. I'm going to see it obviously in your trial exam, or what we call preparatory exam, that which is coming quite soon, and also end of year. All right. Now, what specific sections or specific things are we going to be talking about? Let me just have a look here. We are going to discuss what we call primary nutrients. Okay, we will also be looking at how those fertilizers are produced. Okay, like we will be looking at the nitrogen containing fertilizers. We will also be looking at how fertilizers that contain nutrients like potassium are produced. Okay, and also those that are containing phosphorus. Okay, now we will also explain how to calculate the amount of nutrient content in fertilizers, okay, using the NPK ratio. We will also discuss negative impact of nutrients on the environment. So those are the things that we will be looking at in this lesson here. We'll be discussing those things. Now, quickly, let's just have a look at this here. I've got a drawing here that talks to what we call primary nutrients. Now, what are primary nutrients? Primary nutrients are phosphorus, potassium, nitrogen. Okay? And you know that we always call this the NPK. Okay? Now, I am very grateful to one teacher that taught me this way back. I was still doing what we call Standard 5 then. It is now called Grade 7, where he was teaching us about fertilizers in agricultural sciences. And he said, for you to know those things, just say to yourself, this NPK is Napaka. So you will always remember that. Okay, so I'm grateful because since then I've never forgotten this up to now. So these are the primary nutrients that we're talking about. And the plants absorb these primary nutrients from the soil through the roots. Okay? Now, let's look at how plants function, how they work, how they survive, how they make their own food, because that's what we know about plants. Plants make their own food. Animals eat food made by plants. Okay, so here we've got the sunlight coming or absorbed by the leaves of a plant, the green leaves, so that photosynthesis can actually take place, so we can have food being manufactured by these plants. Apart from that, we also have carbon dioxide, which is essential, of course, for that process of photosynthesis, absorbed by the plants. So the plants take in this carbon dioxide, which we don't need as animals or as human beings, let me put it that way. And out of all these, the plants manufacture food in the form of proteins. We've got different types of oils and carbohydrates, and of course giving out oxygen, something we need to survive. Life cannot exist without oxygen. So this is what plants help us with. All right. But for them to be healthy, for them to grow and produce these foods that we need so that we can eat them and survive, they need nutrients. Napaka, nitrogen, potassium, nitrogen, phosphorus, potassium. Okay, those are your primary nutrients. Okay, these nutrients, of course, like I said, are absorbed as dissolved salts. Okay, we're going to talk more about these salts here. Dissolved salts from the soil. Without nutrients, plants would not be able to make food for animals, so we wouldn't have anything to eat. Now, nutrients, which is what fertilizers would contain, it's where our focus is today in this lesson. Let's move on. Okay, now, here we are. What do the primary nutrients do for plants? Let's have a look at it. One of the primary nutrients, of course, is nitrogen. What does it do to plants? Okay, this nitrogen is absorbed as nitrates by plants. Okay, so the plants do not take in this nutrient or this type of nutrient, nitrogen, as is, N2, no. Or as atoms of nitrogen, N, no. But it takes it in as salts of nitrates. Okay, and if you go back to your grade 11, grade 10 science, you would remember that all nitrates are soluble. Okay, and what does it mean? Look, plants can only absorb dissolved salts as fertilizers, as nutrients into themselves through their roots. So when we have nitrates, they are easily able to dissolve in water, and therefore they can be absorbed by the plants through the roots. So all nitrates are soluble, and when we look at ammonium salts, for example, ammonium salts will contain this. So already you can see that the nitrogen, which is your primary nutrient, is part of that complex ion, NH4. So these ammonium salts are absorbed as well by plants when there's enough water in the ground and it has dissolved there. So from nitrates, for example, okay, even here, you can have this whole thing as ammonium nitrate, for example. So the nitrate is that. If you have these as ammonium nitrate, you would be having this compound here, NH4, NO3, highly soluble in water. And therefore, you have your nitrate, your nitrogen primary nutrient there from those. Okay, now quickly looking at phosphorus. Okay, now maybe before then, let's look at what this nitrogen helps the plants with. It absorbs, plants will absorb this nutrient. What does it do in the plant? In the plant, nitrogen would make the plants to grow healthy stems. For example, the maize plant that we have seen here, that stem has to be strong. Otherwise, it's going to be blown out, or it's going to be pushed away by wind and other things. For healthy, strong stems, you need nitrogen. And of course, the leaves. All right. So you need those leaves to flourish and to be healthy for the plants to produce what we want to produce, the food that we want to produce. Okay. And plants also use nitrogen to produce proteins. Okay. To produce proteins and vitamins. All right. So these proteins we can't live without. Our bodies need those things day in, day out. Without them, we become sick. Without these vitamins, our bodies are not healthy. So we need this from the plants. Phosphorus would be used by plants for the following: development of roots and also for cell development. Now, what we mean by cell development, we know that plants and even animals, of course, but now let's talk about plant cells. Plants are made up of cells, and those cells should grow for the size of the plant to change and become bigger. And that process of cell development is helped by the presence of that nutrient there, phosphorus. Okay. Right. And then moving on, we have potassium as the third primary plant nutrient or primary nutrient. Potassium helps plants in the process of cell division. Now, there is cell growth here or cell development. Now we're talking cell division. Remember the process of mitosis and meiosis, cell division, that the cells have to multiply. As they divide, then the plant grows as well. So when that happens, you need a lot of potassium for the plant to do that. The uptake of nitrogen as a nutrient is helped a lot by the presence of potassium. All right, by the presence of potassium. Now, if you are to check on this, you can see that potassium, you know, when it forms its salt, it can form potassium nitrate. So those nitrates, potassium nitrate, highly soluble, and they can be together because you've got the plus and the minuses there. That intake, potassium being in the stems and everything, pulling on these nitrates, going up into the stem of the plant and helping it to grow. All right. It also helps, this potassium also helps in the production of carbohydrates and during the process of transpiration and respiration. So we know all these things. In the life sciences lessons, you will be learning about them, the guttation and everything, transpiration and respiration. So all those processes, you need good amount of potassium to help those plants to undergo those processes or to do those processes. Okay? Moving on. Right. Now, let's come to this here. Why do we need fertilizers? I've spoken about primary nutrients, what they do to plants and everything. But then why do we need those fertilizers? And of course, these are artificial fertilizers. These are fertilizers that we manufacture from industries. Okay. Earlier on, okay, potassium is found in the form of potash, and of course, it's used mainly for flowering by plants, okay? And we've got nitrates here used for leaf and stem growth, okay? If you want to have healthy leaves and healthy stems of plants, you need the nitrates. And the phosphate, especially for root systems. Strength of the root system depends on the presence of this phosphate, okay? So why do we need these fertilizers? Natural sources of fertilizers, we're going to discuss them, but they can never be enough given the rapid growth of the population. I'm going to give you or show you a picture of what it is like, that population growth, or we can actually call it population explosion because it is growing in a very exponential manner. All right. Animal manure. This is where we would get plant nutrients and also plant compost. Okay, when plants die and we keep them together, we bury them in soil and they decay there, we get that compost. We can get those fertilizers from there naturally. We can also get it from what we call guano, which is actually bird droppings. But we don't have that many or so many birds around that can do that. At some point, this was important from Brazil. I'm not so sure if that is still happening because they've got a lot of it that side. Okay, and we can also get it from bone meal. But all these sources are not sustainable. And because they are not sustainable, we need to have a way of producing these fertilizers industrially so we can have more of them produced locally and use them in our agricultural industries to produce more plants so we can have more food for the people. All right. So this is the picture, if you like, of how the issue of fertilizers is affecting human life. We've got very little from coming naturally. Then you need to make sure that there is something that comes artificially to come and replenish your supply of fertilizers. We're going to proceed after a short break, and from there we'll begin to look at how these fertilizers are manufactured industrially.
All right. Okay. Mindsetters, we are going to take a very short break. Just a quick shout out to Maureen, Abednego, Sianda, Songe, Zomnyanda, Debo Hussein, and Gift. Shout out to you guys. Thank you so much for tuning in. Mindsetters, we will see you straight after this. Welcome back, Mindsetters, from the very short break. We do have a question here from Abednego Mabena, but then I'll read the question, but then TK said you should just chill. He will unpack it nicely for you. So I'll read your question and then keep tuned in, and then TK will unpack it nicely for you. So it says, TK, in the NPK ratio, 3:2:3 with the brackets 30. What does the 30 in the bracket represent? So Abednego, you will go through your question later on. TK said he will do it nicely for you. So hope you stay glued to your screen, TK.
Yeah, it shouldn't move at all. And we are continuing here. And I was talking to you about natural sources of fertilizers. We have explained that, and I think I've also made mention of the fact that this is not sustainable given the population growth that we are experiencing in the world. Okay, because then we need food to feed all these people. Now, moving on here, I want to give you or show you a picture of how the population growth is like over a period of time. Okay, so you would understand why we need those fertilizers here. So I'm talking about human population explosion. So here we're talking about how the numbers of people are increasing worldwide. Okay, let me just explain a little bit this graph here. If you check here, around 1800, we were around 1 billion, okay, people in the whole world. But you come to about the 1900s, that is about a century after, about 100 years later, the growth was like almost about 2.5. Okay, so it's about 2, not even 2.5 here, but just 1.5 billion of people that we were having. So look at it here, about 1.5 billion there. But check the growth from here, 1900 to 2000. Again, another 100 years later, look at the growth. It grew so exponentially. So the number has exploded. Now, we can't survive through subsistence farming when things are like this. So to make sure that we've got food security, there should be a way of producing this food rapidly, okay? More and more of it in very short times, so that we can be able to reach out to these billions of people that are out there and in need of food. So for food security, we therefore need these plant nutrients. We need these fertilizers to be produced in large quantities. You can't wait for bird droppings. You can't wait just to have compost. You can't wait for all those things. For manure, you can't just wait for that. You need more to that. Another problem with natural sources of fertilizers is that when you have that amount of manure in your garden, do you know how much nutrients you have in there, the primary nutrients? Would you know, can you tell how much nitrogen is there, how much phosphorus is there, and how much potassium is there? Definitely you can't tell. And therefore, we needed a better way that can be precise in terms of quantities, so we can know that this type of plants need a lot of the nitrogen, so we can have the others in smaller quantities. Hence that scale that Abednego was asking about just now, but we'll come to that. So this population explosion needs people to respond to it in terms of the producing more food. And it is also predicted that in about half a century, after 2000, in about half a century, 2050, we will be having around 10 billion people in the world. That's huge. That's huge. Given that we started somewhere from just around a billion. Now, in 2050, we will be reaching that amount. So more people would mean more demand for food. Increase in the demand for fertilizers became necessary, okay? And then industrial production of fertilizers had to come in. So scientists had to sit and say, well, from our laboratories, what can we do to produce these plant nutrients? And then we can sell these to farmers and they can use it to nourish their plants so we can have food security in the country. Good. So that is a nice background of what you need to know there about population explosion versus the need for fertilizers. Let's look now at nitrogen-based fertilizers. These are fertilizers that contain nitrogen. How are they produced industrially? Okay. Let's look at the production of ammonium nitrate. Now, in ammonium nitrate, I also want to show you that this is a nitrogen-rich fertilizer, because in just one compound of that, you've got nitrogen there, you've got nitrogen there. So you're bringing a lot of it. So this one would be one of the best nitrogen-rich fertilizers that farmers would like to always have for those plants that need a lot of it. Okay. Now, moving on, and here I've got a flow chart, a flow diagram that shows us how these nitrogen-containing fertilizers are produced. In the first place, nitrogen is a gas. Nitrogen is found in the atmosphere. It is the gas that occupies, or is the largest amount of gas that you can find in the atmosphere. All right. So that serves us well because it means we can harness this nitrogen from the atmosphere and be able to use it in our laboratories and produce nitrogen-containing fertilizers. But how is that done scientifically? As a learner there, you need to know how it is done and understand how the science behind it, because that is what the exam will require you to know. Let's get to it. So there is air full of nitrogen and other gases that we won't need. Then what do we do to get to the level that we get that pure nitrogen gas that we can use? What we do is we use a process called fractional distillation. Okay, so it's fractional distillation. Okay, so this process here, fractional distillation. We use that process to get oxygen. How does this fractional distillation happen? What we do is we liquefy air. So this air here, the air there is liquefied. Liquefied. So you liquefy the air. The word liquefy simply means that change the gas, the air, from being a combination of just gases like that and make it a combination of gases in the liquid form. So we've liquefied it. In the liquid form, when we boil, we apply some heat onto that liquid air, the air begins to evaporate. In other words, the liquid air begins to evaporate. There is a phase change from liquid to gas. Now, because different gases will boil at different points. We make sure that we tune our process, the heating process, such that when we get to a point where nitrogen will boil, so the boiling point of nitrogen, at that point, only nitrogen is going to change from being a liquid to a gas, and we harness that. All right, and once we do that, we have our nitrogen, and then we can be able to use it to produce ammonia. Now, how is ammonia produced? I can hear some of you already talking. How is ammonia produced? Thinking about the process that happens or that should be done or conducted to produce this ammonia. Very, very useful compound in the production of fertilizers. We make use of what we call the Haber process to produce ammonia. Okay, so we produce ammonia through the Haber process, and this Haber process, obviously, you are combining nitrogen, and of course, that is a gas. Let me stick to even showing you the states here, or the phases of these substances here. Nitrogen, hydrogen, gas reacting, and this is a reversible reaction to give you ammonia. It is also a gas at that point, so we can just dissolve it in some water to have it in a liquid form. Okay, so that's what you have. You can balance that equation if you want to. To do that, you would need to just say, okay, nitrogen 2 on the left, I'll need a 2 there, and then the 2 makes the hydrogen 6 on the right because of that. So 2 times 3, 6. So I would have to make this one 6 as well. So that will have to be 3 times 2 to get it to be 6. So that chemical equation is balanced there. And immediately you see those double arrows. It tells you that we've got a reversible reaction, and therefore equilibrium can be reached, and you know, takes you to another concept in physical sciences. And that is why in questioning, in your question paper, examiners like to have this question here under production of fertilizers linked to your equilibrium questions. So watch out for that, because I know they like that. Okay, so you have now, or we have now produced ammonia. And then ammonia, when we allow ammonia to react with nitric acid, we produce the most desired fertilizer, ammonium nitrate. So that's how this flowchart explains the process of the production of nitrogen-containing fertilizers. Okay, good. Now, moving on to the next one, let's have a look at it. We've got another process here, okay? Another process that we have to look at here. Again here, still talking about nitrogen-containing fertilizers, okay? The production of nitric acid this time. The process in which nitric acid is produced is called the Ostwald process, okay? And how does that happen? You need ammonia to produce nitric acid. But let's just quickly go through the steps here that we need to follow to produce nitric acid. Okay, step 1, you need that ammonia, you react it with oxygen, you produce this gas here, which is very critical in this process. And of course, part of the products that are formed, a byproduct if you like, is water, H2O, in the form of gas, so it's water vapor. All right, now from there we would have the second step. The second step, step 2, you've got this gas here that has been produced in stage 1 or step 1 here, which is nitrogen monoxide or nitrous oxide if you like. This one is reacted with oxygen now to give you nitrogen dioxide. And in step 3, this nitrogen dioxide now react or is dissolved in water if you like to give you nitric acid. And what is interesting is that when nitrogen dioxide reacts with water or is dissolved in water, the product is nitric acid, which we are looking for. But a byproduct of that is nitrous oxide, which is very crucial, very important for us to start the process. Because remember, when you at the beginning there, what you need with ammonia, when you have ammonia reacting with water, you produce that one so that you can have step 2. So from there, you can only come back to step 2, for example, and continue to react that nitrogen monoxide with oxygen to give you nitrogen dioxide in that way. So this is quite interesting here. All right. So from there, you have got the nitric acid, which is very crucial in the production of nitrogen-based fertilizers. Okay. Right. So coming to this part here. All right. Coming to this part here. Here we're looking at still continuing talking about nitrogen-based fertilizers, production of ammonium sulfate. Now the fact that we're bringing in this part here, the sulfate, that sulfate must be coming from somewhere. All right, and we'll see how that happens or where we get it. Again, we start from air. We have our nitrogen. I've explained how the nitrogen is harnessed from the air, liquefaction of air, and then you use the process called fractional distillation. A fraction is a part of something, all right? So you've got this mess of gases, and all you need is just that particular one, nitrogen. So you fractionally distillate it so that you can get the nitrogen that you are looking for. All right, so here we are now, and at this point, I want to pause. We have an ad break, and we're going to come back and proceed from this flow diagram here.
All right. Mindsetters, we are going to take a very short break, so don't go anywhere. We will be back straight after this. Welcome back, Mindsetters, from that very nice little break you had there. I hope you guys are still on par with TK and you're learning with him as he's teaching you about these fertilizers. So I won't waste any more time. I'll take it straight back to TK.
Thank you, Lini. And let's move on quickly. So here we're still talking about nitrogen-based fertilizers. We have explained the fractional distillation part here, where we get hold of our nitrogen so we can produce ammonia. We have also, of course, explained how ammonia is produced. So that is all done. We have also, so out of this, we want to check how do we end up having what we call ammonium sulfate as one of our fertilizers. So for us to get the sulfate, like I said earlier on before the break, that sulfate part, you had, I mean, it's ammonium sulfate. We know about the ammonium part. The sulfate part, where is it coming from? You need to know that the sulfate part comes from what we call sulfuric acid, and specifically the sulfate is the SO4 there. Okay, so the sulfuric acid together with ammonia gives us what we call ammonium sulfate. I want you to take cognizance of that particular chemical formula there, how it is written down. You need to know your chemical formulas of all these things. Some, I think you remember questions in your exams that will say, write down the name or formulae of whatever. So you need to know your chemical formulas. Okay, right, moving on. Let's see what we have next here. Now that sulfuric acid, because it is there, how do we get to have the sulfuric acid? Okay, how do we end up having sulfuric acid? Let's look at it. Production of sulfuric acid. Okay, production of sulfuric acid. Again, from air, we know that. Okay, we've got the oxygen, from the oxygen, and it's again fractional distillation, we get the oxygen. Oxygen in step 1 is made to react with sulfur to give us sulfur dioxide. Okay? Now, when sulfur dioxide is there, what happens? We then take this sulfur dioxide in our step 2, we make it to react with oxygen as well, and what do we produce? We produce what we call sulfur trioxide, SO3, okay? And this reaction here happens in the presence of a catalyst, vanadium oxide, and it is that because all substances here are in contact with the vanadium oxide for this reaction to take place, and for that reason this process here is called the contact process, and we're going to see until the end how this sulfuric acid is produced. Okay, so in step 3, remember now we now have sulfur trioxide. That sulfur trioxide is made to react with sulfuric acid, okay? Sulfuric acid in a liquid form to produce that pyrite sulfuric acid or oleum, okay? All right, so that's what we have there, and this highly concentrated sulfuric acid is now placed inside water, dissolved to give us our sulfuric acid here, and this is the contact process. In short, this is how the contact process happens. So you need to know all these steps. You need to know the chemical formulas of all the substances involved in those steps there. Right? Let's come to questions now, and I think through these questions we'll be able to answer most of the questions that you are asking, including the one that Abednego asked earlier on. All right. What are the processes used to produce the following substances? What do we call them? When we are to produce nitrogen, capturing it from air, we use a process called fractional distillation. Okay? Fractional distillation. Fractional distillation. And when we are to produce ammonia, I think everyone should know this. Please go and get everything wrong in the exam, but don't get this one wrong at all. But hey, I'm not saying you must get everything. You must get everything right in the exam. So ammonia, we use what we call Haber process. Okay? You must know all this. For nitric acid, we use the Ostwald process. Ostwald process. I can hear voices of some of you following it up with me and saying these processes. For sulfuric acid, what process are we using? We use what we call the contact process. Okay, we use contact process. Right. Next, still moving on, talking about questions. This is question number 2. Ammonia, ammonium nitrate, and ammonium sulfate are 3 important nitrogen-containing fertilizers. The following diagram below shows how these fertilizers are produced, okay? So that's what we have there. We have A there, process 1. We have explained that already. To nitrogen, that is fractional distillation. You can see that. And there we've got the contact process. Process 2, it's nitrogen and hydrogen. What is this one? This is the Haber process, okay? This is Haber process. Okay, and compound Y is produced. What will be compound Y when you have got nitrogen and hydrogen? That will be ammonia, okay? Because that is what is produced in Haber process. If you have Ostwald process, which is now compound Y reacting with another compound here, you're going to produce ammonium nitrate. What is this compound X here? Compound X has to be nitric acid for you to produce ammonium nitrate, okay? And then down here, when you have the contact process, sulfur trioxide, sulfuric acid, down here you have got ammonium sulfate. What has happened? It means you have had ammonia and sulfuric acid there to produce that one, okay? So I have answered these questions here if you like, so I'm not going to do a lot, but let's come to B. Balance the equation for process 2. If you go back to the chart, process 2 is the one where ammonia is formed, is the Haber process. So you're going to have N2 plus H2 giving you NH3. And the question is saying balanced. So it means you're going to put a 2 there and a 3 there. Then you get all the marks. In fact, that should be the answer for number B. I should have written it down there. C, name or formula of compound X. We have already, I have already showed you what compound X is. It's HNO3, which is nitric acid. Okay, so let me choose to write down the formula. Balance the equation for the preparation of ammonium sulfate using sulfuric acid and compound Y, ammonium sulfate. So you've got, and what is compound Y? You can go back to compound Y, look at it. There is compound 1, NH3. All right, so you're going to have NH3 plus sulfuric acid, giving you ammonium sulfate, which is going to be NH4. Remember, 2 there, S of 4. So they want you to write it correctly like that. And you have to balance it. What do you have here? You've got 8 hydrogens. You've got 8 hydrogens on the right. You've got 5 on the left. So what are you going to do? You've got 2 there. It means you're going to put a 2 here so that you've got 2 nitrogens, 6 hydrogen, 8, then 8 on the right, and you are sorted. So that's how you will balance it. Now, quickly, I want us to have a look again at the last part of this question here, where we've got, okay, we still have a few here. E, name or symbol of the primary nutrient in ammonium sulfate. Now, primary nutrient in ammonium sulfate is nitrogen. Write down 1 positive impact of fertilizers on humans. Now, what do we gain from fertilizers? When the industrial world is producing these nitrogen or these fertilizers, let me put it that way, you need people to be employed there. So people gain employment from the production of fertilizers. So people are employed. All right, to produce fertilizers. So this is a positive impact on humans, okay? And they also get enough food. There is food security. Don't want to write a lot of things because I've got other questions to look at. So let me just stop there. Now, 2 negative impacts of the use of ammonium nitrate as a fertilizer on humans. 1, this would cause things like eutrophication. Okay, and what is that? That is excessive fertilizers in or washed into rivers, all right? Washed into rivers and dams. Okay, depleting the oxygen in the water. And water causing aquatic, let me just say, okay, aquatic plants and animals to die. Okay, aquatic animals like fish and plants, okay, to die. Okay, but then how does this happen? These fertilizers, when they are in rivers, they cause things like algae to bloom. Okay, so you've got too much of it there. Then they use that oxygen, they deplete the oxygen from the water, so that leads into animal life in the water dying, and also plants that are actually surviving in water. Okay, so we can have another one there. I want you to think about it, right? I want to move so that because of the time that I have, I want to finish some of the questions that are crucial, especially some of the calculations based on the fertilizer ratios. Okay, so here we've got the phosphate. I'm not going to talk much about the phosphate containing fertilizers, but what you need to know is that this is mined. You are mining what we call the phosphate rock, and that's what they do in mines like in Palabura, where they produce this rock, and this rock needs to be dissolved in sulfuric acid so that you can produce something that can be dissolved in water, because this part here, this rock, phosphate rock here, it's insoluble in water. And if it's insoluble in water, plants may not be able to use it. Okay, so you need to dissolve it in concentrated sulfuric acid to be able to be used by the plants. Okay, with potassium, we import it. Okay, it's not available in our country. We import it from other countries. All right, potassium-containing fertilizers. And then quickly, this is where I really want us to be, and this is where I believe Abednego will be happy to see. All right, here is a bag of fertilizers, okay? And you can see there we've got ratios, 18, 24, 6. Potassium, nitrogen, phosphorus. Okay, that's what you have. We also have that, and let me draw your attention more to that. NPK. That's how it is written. And then if you see the ratio, 1:3:1, it means the first one is nitrogen, the second one is phosphorus, and the last one is potassium. In this example, for example, a bag of fertilizers can be marked as follows: 3:1:4, and you've got in brackets 26. And Abednego, I believe you are watching and listening carefully. This 26 here simply tells you that 26% of the bag is fertilizers. So 26% of the content of that bag, it's fertilizers. Then what is this 74% made up of? This is just made up of a filler, just something to help you spread your fertilizers in your land, in your cultivated land. It has got nothing to do with fertilizers. Okay, and in this 26% here, the ratio is according to that. So the 3 is for nitrogen, the 1 is for phosphorus, and the 4 is for, so this is P, sorry, and the 4 is for K, potassium. So this is NPK. NPK. All right. So if I were to find out the percentage composition of nitrogen, phosphorus, and potassium in that bag, for nitrogen, it's 3. So it's 3 of the total ratio. What is our total ratio? Total ratio is your total ratio. So you can work it out first if you like, you show it. Total ratio, you add them together. 3 plus 1 plus 4 equals 8. Okay? So you would say for nitrogen, percentage composition will be equal to, it's 3 for nitrogen, so 3 the first one for N, divided by the total ratio times what that number is. So it's 26. In Abednego's question, he was using 30. Huh? Mm-hmm. So it doesn't matter what you have, Abednego, just follow this one out. And then this will give you a percentage for nitrogen. You come to phosphorus, the same thing. You will say for phosphorus, it's 1 of the 8 times 26. Then you will get the percentage composition for your phosphorus here. So percentage composition for P will be given by that. It will be equal to 1 over 8 of that. Then the percentage composition of potassium will be given by, what is the ratio for potassium is 4. It will be 4 out of 8 times 26. And then, of course, you work it out. You have your calculators there. Quickly, you can do all those calculations and finish off. Now, environmental impact, just to close up here, all right? The excessive use of artificial fertilizers leads to what we call eutrophication. How does this happen? Rain leaches excessive fertilizers into rivers and dams, causing the growth of algae to increase. So you've got too much of this algae in the dams and rivers, okay? Blooming. I think you have seen this before. And when that happens, the algae, when it dies, it decomposes and it depletes the oxygen inside the water. This leads to what? To suffocation of aquatic animals, such as fish and others, okay? And they eventually die. So when that happens, those areas where such a thing has happened is called, or those areas are called dead zones. Dead zones. Everything is dead there. The very algae that was blooming is now dead. Aquatic animals are dead. So everything is dead there. So here we've got some pictures of what we're talking about. Don't be thinking that what you see there is some nice lawn in some park somewhere. This is actually a dead zone where you're having too much of the algae actually blooming there. Okay? Blooming there, and what is going to be the end? We're going to have a dead zone there. That's what is going to happen as time goes on. So that is the effect of fertilizers. Farmers and whoever is using fertilizers for your agricultural work, you need to use fertilizers sparingly. Don't be excessive in the use of fertilizers. You have to be careful. Don't use more than you need. Okay, all right? Let's look at this one here. Fertilizers allow farmers to grow crops in the same soil year after year. However, environmental problems such as eutrophication, what I've just explained now, are associated with the application of fertilizers. Okay, so here we're talking about these the negative impact of fertilizers. All right, you will find these questions in the notes in the net where you can download them and you can talk to them. But let me just answer a few. Maybe the first one here. State one precaution that a maize farmer can take to prevent eutrophication. I've mentioned that you will need to, a farmer would have to ensure that fertilizers are used sparingly, okay? Fertilizers are used sparingly. Don't just do bucket chemistry, okay? Right, sparingly to ensure that that doesn't happen. Guys, it is that time where the lesson has to come to an end. I wish we had more time, but we have to take it up to this point. I hope you enjoyed this lesson. Let me give it back to Lini.
All right. Mindsetters, thank you so much for tuning in. Everything of the best with your prelim exams. I hope the preparations are going well and you guys are enjoying every minute of preparing for the last few days of your matric career. Do best, guys, and just enjoy every bit of it. And remember to always learn more and learn extra. Thank you to Macmillan for sponsoring our great show. And until next time, bye.
Bye-bye.